So today what we're going to do is cover the last section of chapter 1, it's section 6, and today we're going to learn how to describe angle pair relationships. Now this is a really important lesson. It's going to have a lot of useful information, and you're going to see a lot of this maybe on a PSAT or an SAT. So it's important information. So the first thing we're going to talk about are complementary, supplementary, and adjacent angles. Now you've probably seen complementary and supplementary angles, probably in elementary school and maybe even in your middle school classes. So complementary angles are just, the definition is, what's important here is two angles whose measurements have the sum of 90 degrees. Supplementary angles are two angles, both of these are always a pair, two angles whose measures have the sum of 180. Now, when we're looking for a pair of complementary or supplementary angles, they don't have to be adjacent. So if I give you a picture and I say, find a pair, they don't have to be right next to each other. And that's the next definition, adjacent. So adjacent angles are just two angles that share a common vertex and a side, but they have no common interior points. So in other words, they're right next to each other. So in the pictures here, and they can't overlap, that's what it means, no interior points together. So in the picture here for the complementary angles, angles 1 and 2, they are both 90 degrees together when you add them. They are both adjacent because they share this common vertex here and this side. So let's say I told you that this angle was 20. I'm just making up numbers. This is 20 and this is 70. When you add them, they're going to add up to be 90 degrees, which makes them complementary angles. Now, what I found in the past is sometimes students forget or they get them mixed up. So maybe a little way to help you remember the difference between complementary and supplementary. If you think about the word complementary, what I like to do is think of this C. If I put a line straight down, this sort of looks like I just made the first two letters a 90. And then for supplementary, if I take the S and I put a line down diagonally like this, that sort of looks like I just made that into an 8. And then you could close up the U and then add a 1 there. That would be your sum to 180. Whatever tricks are going to help you remember that complementary are two angles that add to 90, supplementary two angles that add up to be 180. Sometimes what I also think about is if you were to write out the letters in the alphabet, A, B, C, D, E, F, and then all the way get here to Q, R, S, T. So where the C is and where the S is, I sort of think of this as like a number line as well. And C is the smaller part of the beginning of the alphabet, so it goes with the smaller number. Whatever's going to help you to remember that the complementary are two angles that add up to be 90, and supplementary are two angles that add up to be 180. Now, notice these two here in this picture, 3 and 4. These are non-adjacent, but if I tell you angle 3 is 30 and angle 4 is 60, they're still complementary angles because when you add them, they add up to be 90. Then for the supplements, whenever you see a straight line, and if they take that line and they split it, you're going to realize that a straight angle or a straight line is 180 degrees. So if I were to split that, and let's say I told you that this was 100 and this one was 80, you're going to see that there's supplements. So same thing here. If I told you this was 120 and I asked you to find the other one, you could just subtract 180 minus 120 And you can see that the missing one would be 60. Same thing here. Let's say this is 110. So then this one would be 70. If you are told that 7 and 8 together are supplements. We will be using these complementary and supplementary angles a lot in our proofs when we start writing proofs in the next chapter. All right, so here it says use the figure to make a pair of complementary angles, supplementary angles, and adjacent angles. So how much do complementary, the two angles together, add up to be? 90 degrees, good. So I'm looking for two angles in my picture that when I add them are going to add up to be 90. Now, remember, when you have two angles sharing the same vertex, you need to use 3 letters to name it. So when I go to name any of the angles in this picture, I'm going to need to name them with 3 letters. However, the angle that's over here, I can either name this RST or in reverse, TSR, or I could get away with just saying it's angle S because there's only one angle S there. So let's go ahead and look for the angles. So notice I've got a 32 degree angle right here in my angle BAC or CAB, and then I've got a 58. So if I go ahead and add 58 plus 32, I get 90 degrees. So my angle pairs that are complements, and again, you need the little symbol, so I could either name this one CAB, or I could name it in reverse, BAC, and then together with angle, either name it RST, or in reverse, TSR, or you could name it angle S. So you're going to make either this one with this, or you could have put it with this one or this one, but one from the first column and match it with. Everybody good on the complement? Yes. If you were writing a proof, what you would do is you could say that angle CAB plus angle RST equal 90 degrees. You could do that. But if it just asks you to list them, you could just put CAB and then one of these. Does that make sense? Okay, so now we need to look for the supplement. So I've got 122 degree angle here. Notice that this is not a straight line. So when I try to add 122 and 32, it's not going to give me 180. But if I try to add 122 and the 58, this is going to give me the 180 I need for the supplements. So again, when I'm naming the one with the vertex of A, I need to use 3 letters. So I'm going to go ahead and call this CAD, or in reverse, DAC, and then together with this one as well, the RST. And again, put the angle symbol in front or in reverse, and then angle S. So any combination, you don't need to list everything. So I could have just said that. Now on the test, when I ask you, if I give you a question like this, and I say, list a pair of complementary angles, don't give me more than one, okay? Give me the one answer that you are 100% sure on, because if you give me 2 answers and one is wrong, you lose everything. Because in the past, I've had students who aren't sure and they think they could get away with putting 2 answers because they're not sure which one is right, and then one's right, one's wrong. You lose everything. No partial credit if you give me more than one answer and I only ask you for one thing, and if they're both wrong. If they're both right, you get full credit. Everybody good on that? All right, next, it wants adjacent angles. So remember, for 2 angles to be adjacent, they need to have a common side and a common vertex. So common side and vertex. So the angles that are adjacent in this picture are going to be these two. And again, I need to name them with 3 letters. So I can name it as angle DAC along with angle CAB. So I could write the word and. If I would have listed it in reverse, CAD, and this one in reverse, BAC, either way. But again, you need to name them with 3 letters. You can't just say angle A because there's 2 different angle A's in the picture. So we've got a real life example here, tying it into sports. So it says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. It wants us to find the measure of angle BCE. So BCE, let me highlight it here. BCE is right here along the ground and up the ball return net. And then ECD is over here. And they want us to find the measure of both angles. So remember, supplementary angles are 2 angles when you add them, and they add up to be 180. So what I'm going to be doing here is adding the measure of angle BCE plus ECD and set that equal to 180. So remember, BCE, this one is the 4x plus 8. ECD, I don't know if this is going to show up. I'll just write it in black. ECD was x plus 2. And then we set it equal to 180. So we're using our algebra skills. The picture here, this looks like an exponent, but it's a degree symbol. It's just a little circle. So if this ever happens on a test or a quiz and you're not sure, like maybe the print didn't come out clearly, you can always ask me something like that if you get a test in front of you and you can't read something. Okay, so just make sure you're understanding exactly what you're reading, because sometimes the pictures get kind of fuzzy. Okay, so let's go ahead, use our Algebra 1 skills. We're going to combine like terms. So I'm going to combine 4x with 1x. I get 5x. And then my constants, 8 plus 2 is 10. And now I have a 2-step equation. So I start with my inverse operations. So I'm going to subtract 10 from both sides first. 5x equals 170. Divide by 5. And x equals 34. Now the question did not ask for x. It asked me to find the measure of the 2 angles. So remember, the measure of angle BCE was the 4x plus 8. So I'm now going to take my newly found value of x and replace it and substitute it in. So I'll do 4 times 34 and then add 8. I get 136 plus 8. And this angle measure is 144 degrees. I'll do exactly the same thing to find the measure of ECD. My expression was x plus 2, so 34 plus 2, and I get 36. Now, technically, I could have just found the first angle and subtract it from 180, but I always like to plug it in. And then one way that you can confirm that you did do it correctly, remember, when you add these 2 together, it should add up to be 180. So let's check it. And if it doesn't, then I would definitely go back and check to see if you've made a careless mistake. So it does check out. They do add up to be 180. So the measure of BCE, 144. The measure of ECD is 36. Okay, 2 more definitions. The first one is the definition of a linear pair. And a linear pair are 2 adjacent angles when non-common sides are opposite rays. They're always going to form supplementary angles. So in the picture here, This is an example of a linear pair. So it says two adjacent angles. So I have angle 1 here. And then I have angle 2. And it says when non-common sides are opposite rays. So the common side is right here where I see the red and the blue, which I just made purple. The non-common sides would be just the blue and just the red, because the color didn't overlap. So when you see something like this, this is an example of a linear pair. And know that these two angles, 1 and 2, are also supplements. So if I ask you to describe angles 1 and 2, you could tell me they're a linear pair. You could tell me they're supplementary angles. And you could also tell me they're adjacent. Then for vertical angles, these are two angles whose sides form two pairs of opposite rays. So basically what's going to form a pair of vertical angles are going to be two intersecting lines. However, if I were to take my definition here, and let's say I have angle 4, and if I create that by tracing over, and then if I were to trace over angle 5, notice it says there are two angles whose sides form two pairs of opposite rays. So I have opposite rays here. The blue is going in one direction and the red in the other. And then I also have a pair of opposite rays going this way. What we're going to be seeing coming up is that vertical angles, those pairs, are going to be congruent. So in this picture, if I told you that angle 4 was 110, if you recognize that 4 and 6 are a linear pair, or even 3 and 4, you could do 180 minus 110 and realize this one, because it's a linear pair, is going to be 70. So will this one, and then you could make it go around this way as well. So these vertical angles are going to be congruent. We're going to see that coming up. We're going to learn a theorem. And then these would also be congruent over here. One way that you might want to help to remember this is, again, if you've got your intersecting lines, and again, I've got a vertical angle right here, and then another one right here. Sort of think of this as spelling, this looks like a V, and then you could draw a line here, and this could be like an A. So vertical angles. You could also do it sideways, a V and an A, but those are the locations of your vertical angles. So right now, all you need to know is the definition of how they're formed. Okay, so for here it says, we're tying this into algebra, so we're going to turn this into an algebraic equation. It says two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. Now, I'm going to go ahead and give myself a visual. So I know I've got a linear pair. So it says, I'm going to let X be my first angle, and then the other angle is 5 times that angle. So now, remember, a linear pair adds up to be 180. So now I'm going to add X plus 5X and set it equal to 180. I'm going to combine my like terms. So 1X plus 5X is 6X. Divide by 6. And X is equal to 30. So that's the first angle. To find the second angle, we take 5X and we're going to plug in 30. So 5 times 30, and I get 150. So the measure of each angle One is 30 degrees, the other one is 150. And if you go back and try to plug it in, see if it makes sense. So if the first angle is 30, 5 times 30 is 150, so it's 5 times that measure. And then if you were to go back and add these, remember, these were a linear pair, and linear pairs are supplements, so 30 plus 150 is 180. Let's try another word problem using these definitions. Another word problem. This time we're going to use our knowledge of complementary angles. So here you need to know that there are two angles that when you add them, they're going to be 90. Now let me just give you a little preview before we try to attempt this. Let's say I give you a picture like this, and I'm going to draw the little box indicating that I got a right angle. But let's say I draw an array and I split it. Let's say I tell you this one is 40, and I ask you to find the measure of the other angle. What would you do to find that measure? Beautiful. Okay, we would be doing 90 minus 40, and that would give us the value of x. So we could find out that our x was 50. So this is the idea we're going to use in this word problem. The complement is going to be 90 minus x. This is what we're going to use in our problem. So what we're going to do here, it says the measure of an angle is twice the measure of its complement. So I'm going to let x, and I'm going to translate this. So the measure of an angle, so I'm going to let that be x. The word is my equal sign. Twice means 2 times. And then remember, I just defined the complement to be 90 minus x. This is the equation that I'm going to be solving to find the answer. So if I go ahead, write it down again here, use my algebra skills, distribute, then drop down this side. I need to combine my like terms, so I'm going to add 2x to both sides. And I get 3x equals 180. Divide by 3, and x equals 60. Remember, x was the angle. And now to find its complement, I do 90 minus 60, and the complement is 30. So the next slide is just a little summary of how you can interpret a diagram or a picture that's given to you. And it's telling you what you can conclude or what you can assume and what you can't. So in this picture, we can tell from the picture that all of these points are coplanar. We could also tell that this is going to be a straight line. And we could say that points A, B, and C are collinear. We could also say that these are all rays that intersect at point B. We could also say that this angle, ABD, is adjacent to angle DEB, or we could say DBE is also adjacent to EBC. These are all things that we can conclude from that picture. Now, from the picture, the way it's printed up here at the top, I cannot assume that this angle right here is a right angle without the box. I also can't assume that B is the midpoint because I don't have any congruency marks. I also can't say that these two angles are congruent. Now, if they had markings like that down at the bottom, then I could say, yes, because it's got the little box, it is a right angle. Yes, AB is equal to BC and B is the midpoint because of those congruency marks. So without any kind of markings, you can't conclude anything for sure. You need to be given measurements or congruency marks. So never assume. Let's try the last example. So the last one, it says to use the diagram and to solve for the indicated angle measures. So for the first one, it wants me to find the measure of EFH. So EFH is right here. So notice this is a linear pair. It's sitting on a straight angle. So what I can do is I know a linear pair is a supplement. So I'm going to add 3x minus 6 to this angle over here, HFG, to x plus 16, and set it equal to 180. So I'm going to go ahead and combine my like terms. 3x plus 2x is 5x. And then negative 6 plus 16 is 10. Use my algebra skills. 5x equals 170. Divide by 5. And x equals 34. Notice that was the same equation that I ended up solving before. Now, remember, read questions carefully. It didn't want x. It wanted me to find the measure of EFH. So the measure of EFH was represented by the expression 3x minus 6. So I'm going to replace x with 34. I'm going to multiply it by 3 and then subtract 6. Once I do that, I get 96 degrees. Now, if it would have asked for HFG, then I would have plugged it into the 2x plus 16. But they just wanted me to find that one angle, so it's 96 degrees. And you would put the little degree symbol above the 96. The last one, they want me to find the measure of ABC. ABC is right here. Notice the little right angle mark, indicating that these are complements. And when I add the two together, they're going to add up to be 90. So I'm going to be adding x plus 9 plus this angle here, which is 2x. And I'm going to set it equal to 90 degrees. Going to combine my like terms. 1x plus 2x is 3x. 9. And now I solve. Subtract 9. 3x equals 81. Divide by 3. And x equals 27. Didn't ask for x. It wanted ABC. So I take my newly found value of x, and I'm going to plug it in. The measure of ABC was x plus 9. So 27 plus 9, and it's 36 degrees. If it asked me to find angle CBD, I would have done 2 times 27, and that angle would have been 54. And again, you can confirm by adding them and make sure they add up to be 90. But on the test, make sure you read precisely what I'm asking for.